Hey guys, Trig day number 4 here. Topics for the day are half-angle identities as well as proving, also known as verifying trig identities. So half-angle identity, I've got these three expressions here. No difference really between a, b, and x, just a different variable for the angle. But the half-angle identities that we'll talk about here in the slides to come are very helpful later on when we're integrating problems like the following. All right, cosine squared x and sine squared x by traditional integration methods are not very easy. So we're going to use what's called the power reducing formula, which is the half angle identity, in order to integrate those later on in this course. So let's go ahead and get started. First, let's talk about half angle for cosine. Okay, this is called the power reducing formula. Okay, because it can take cosine squared and turn it into cosine of 2x where cosine is not squared, which makes it much more easy to integrate later on. I'm not doing that right now. It's just kind of a side note. So that power reducing thing is just something I wanted to make you familiar with at this point. But what I do want to come up with is the half angle involving cosine. So what I do is I take cosine of 2x, which is equal to 2 cosine squared x minus 1. And what I'm going to do is I'm going to do a quick substitution. I'm going to call u 2x, and I'm going to call then x u over 2. So what I've got then is 2 cosine squared u over 2 minus 1 is equal to cosine of u. So what I'm doing is, as you can see, is I'm going to come up with a half angle identity using u over 2 given u. Now you could already see that x is half of 2x, but just formally we can go through it this way. Now I'm going to add 1 and divide by 2. So I'll get cosine squared u over 2 is equal to 1 plus cosine of u over 2. So then cosine of u over 2 is equal to plus or minus the square root of 1 plus cosine of u over 2. So cosine of x over 2, very similarly, will be plus or minus 1 plus cosine of x over 2. All right, there's cosine of x over 2. Let's look at sine of x over 2. Now, again, I'm going to use cosine 2x and the fact that it ties together with sine x, or sine squared x. I could use the same substitution. So if u is equal to 2x, then x is equal to u over 2. So 1 minus 2 sine squared u over 2. Sorry if you can hear my dog eating in the background. Maybe now you're just hearing it, but I'll try to talk over it. Let's solve for sine of u over 2. So we're going to subtract 1 and then divide by a negative 2. So I'm going to get sine squared u over 2 subtracting 1 dividing by a negative 2. Okay, I'm going to rearrange that to be, I'm going to use this negative here in the denominator and flip the numerator sign. So that'll be 1 minus cosine of u over 2. So the sine of u over 2 is equal to plus or minus the square root of 1 minus cosine of u over 2. You can see how closely related that is to cosine of x over 2. Just a change in the sign in between 1 and cosine. Okay, cool. Now, tangent x over 2 has 3 different formulas. The most common of the formulas you can see down here, which is sine x over 1 plus cosine x. The others are, actually I forget them right now. There we go. Okay, so the others are 1 minus cosine of x over sine x. And the third is this plus or minus the square root of 1 minus cosine of x over 1 plus the cosine of x. Now, each of those can be more advantageous than the others depending on the scenario. Not something you need to be able to derive like we did here above for sine and for cosine, but I believe you will be given that on your formula sheet. So just something to be aware of. Let's get on to some examples. Okay, so let's start with proving, also known as verifying identities. So in verifying or proving identities, the first thing you're going to want to do is you can only work on one side at a time. Well, actually one side. You have to pick one. Okay? And you always want to pick the most complicated side. It's going to be easier to go from complicated to simple than it is to go from simple to complicated. And number 3, you just want to verify or prove. So you want to end up getting the other side. Okay, an equivalent statement. Verify or prove equality. Okay, so I'm going to prove that sine 2 theta over 1 plus cosine 2 theta minus tangent equals 0. So basically what I want to do is I want to show that this expression equals tangent. Therefore, then we could subtract tangent and get 0. So on the side, I'm going to note that sine 2 theta is equal to 2 sine theta cosine theta. That's going to replace numerator. I think that'll help me. And cosine 2 theta. What should we do here? I'm going to go with 2 cosine squared theta minus 1. Okay, I'm going to replace just the cosine 2 theta in the denominator with that. So let's do that. 2 sine theta, replace it in the numerator, cosine theta. Denominator, 1 plus replacing cosine 2 theta with 2 cosine squared minus 1. Okay, I'm just working the right side, or the left side, sorry. I'm going to show that the left side equals 0. Okay, so what you'll notice then is that the 1's reduce. You'll also notice that the 2's reduce after that. So I'm left with sine theta cosine theta over cosine squared theta minus tangent. And we want to show it equals 0. So I'm just leaving that right side alone, not doing any work with it. I can reduce out one of the cosines in the denominator with the cosine in the numerator. So I get sine theta over cosine theta minus tangent theta. Well, sine theta over cosine theta is equal to tangent theta. Therefore, I've shown it equals 0. There we go. We have verified or proved that first identity. All right, let's move on to the second one here. It says prove the following. I picked the more complicated side. I'm going to work simply on that side, which is on the left. Let's see here. I'm going to use, first I'm going to get a common denominator, and I'm going to expand both the sine of 2x and the cosine of 2x. So let's do that. So it'll be 2 sine x cosine x. All right, and we'll go 2 cosine squared x minus 1 again. Now, if you use the wrong version of cosine 2x, you'll still get to where you want to be. It'll just take longer. Okay, just a heads up on that. All right, so I'm going to get a common denominator of sine x cosine x. And how I do that, right, is by multiplying top and bottom of the first term times cosine x and top and bottom of the second term times sine x. All right, then I can combine these, and of course that's going to be some subtraction there. I want to show this whole thing equals secant. Okay, so let's work. I'll go in red here. I'm going to distribute. Since that's one term, I just distribute it. So I'm going to get 2 sine x cosine squared x. All right, and then on the right hand side, I got to distribute it here and here since there's 2 terms. So I will have, let's see here, remember we're subtracting this whole expression, so that'd be 2 sine x cosine squared x. I like where that's coming from. And then minus sine x. Okay, and that's all over, again, sine x cosine x. Okay, so what do we end up with here? You'll see that the 2 sine x cosine squared x minus 2 sine x cosine squared x will be 0. And then we have to distribute the negative also to that term, which makes the numerator just sine x. So I'll get sine x over sine x cosine x. This is, I don't know why, but I left a huge gap there. It doesn't matter, whatever. Sine x is reduced, so I am left with 1 over cosine x. And 1 over cosine x, folks, is equal to the secant of x. We're good. All right, we verified that. Let's move on to a few other scenarios using half angle or sum, I guess compound angle or double angles. So let's get to it. Okay, some practice on the concept of compound angle. So if you look at this, you should see tan of A minus tan of B, right? So we could say that A equals 80 and B equals 20. So if you have tan of A minus tan of B over 1 plus tan A times tan B, right? So tan A minus tan B over 1 minus tan A tan B. All right, that's equal to tan A minus B. So this is technically the tangent of 80 minus 20, which is 60. Okay, so if I sketch a triangle with a 60 right here, that means this is a 30. So I'd have a 1 root 3 and a 2. Okay, so what would the tangent of 60 equal? Well, the tangent of 60 would then equal square root of 3 over 1. And there's our answer. So that ratio right there is equivalent to the square root of 3. It's kind of cool. Okay, let's look at number 4. Tan A plus B is 3/5. And the tangent of B is 2/3. So that means I'd have the tangent of A plus the tangent of B, which I already know is 2/3, over 1 minus tan A times tan B, which is 2/3. Okay, so what I'm going to do is a little cross multiplication here, and we're going to solve for tan A and leave it in exact form. So I'm going to take 5, multiply it by the numerator, so it would be 5 tangent of A plus 10/3. And 3 crossed with the denominator would be 3 minus, now 2/3 times 3 would be 2. That'd be 2 tan A. All right, so I'm going to add 2 tan A to the left. That makes this 7 tangent of A. And I'm going to subtract 10/3 from the right. Well, this is 9/3. I'm a little busy. Let me finish, please.
Let me tell you something.
Okay, after the pause there, I got 9/3. I'm going to subtract 10/3 from 9/3. I get negative 1/3. So I divide by 7, giving me that the tangent of A is negative 1 over 21. There we go. We got the tangent of A. Let's look at number 5. If B is acute, cosine of 2B, or 2 beta, is negative 7/9. Find without a calculator. So what you should be thinking immediately is, how do I tie cosine 2 beta to cosine beta, right? Or how do I tie cosine 2 beta to sine beta? And the answer to both of those is the different forms or the different interpretations of cosine 2 beta. So cosine beta would be 2 cosine squared beta, minus 1 would equal cosine 2 beta. And so what I'm going to do then is just set equal 2 cosine squared beta minus 1 equal to negative 7/9. And then on the other side, I know that 1 minus 2 sine squared beta is equal to cosine 2 beta. So I would write equal to negative 7/9 there. And now I'm just going to solve for both cosine beta and sine beta. Let's do that. Use a black pen here. I'm going to add 1 to negative 7/9, which gives me 2/9. So 2 cosine squared beta is equal to 2/9. Divide by 2, I get cosine squared beta is equal to 1/9. And then I take the square root of both sides, so cosine of beta is plus or minus 1/3. Now, with this, you might think there's 2 answers. There's not. There's only one. B is acute, or beta is acute. Therefore, I'm going to take the positive, because I'm in quadrant 1, right? If it's acute, that angle would be in quadrant 1, which would mean cosine would have to be positive 1/3. Okay, so I know cosine beta is 1/3. Similar restrictions on the other side. I'm going to subtract 1, which is 9/9. So if I subtract 9/9 from -7/9, I get -16/9. I divide by -2. Dividing by -2, I get 8/9. Taking the square root. Square root of 8 is really 2√2 over square root of 9. Okay. Oops, I guess I forgot that once you use the square root, you no longer need that. Okay, so here we go. That would be plus or minus. Now, since beta is acute, that would have to be in quadrant 1. And in quadrant 1, we know sine is positive. Therefore, sine beta would be 2√2 over 3. If you left this as √8 over 3, I'm guessing that would be okay. But best case would be fully reduced. Okay, let's look at, I believe, one more problem, a challenge problem. Okay, so this is considered a challenging type of example. I would say once you have the setup, it is no more difficult than any of the previous problems. It's just the setup that's going to require some work. So this angle here is alpha. I'm going to call this angle here beta. Oops, beta. So this angle is alpha plus beta. So you can already see where we're going here. So if I know that the tangent of alpha is unknown, but I know the tangent of beta, right, because I'm in a right triangle. Tangent of beta would be opposite over adjacent, which is 3/10. And I also know the tangent of alpha plus beta is equal to 5 plus 3, which would be 8 over 10. So now I know the tangent of alpha plus beta, which is 8/10, is equal to the tangent of alpha, which is unknown, plus the tangent of beta, which is 3/10, over 1 minus tangent alpha, tangent beta. So I'm going to put 3/10 tangent alpha. Okay, so we're going to do a solve for tangent alpha. We did this in a previous problem, so this should not be that challenging. It's just the setup and kind of the overlapping triangle situation that we've got here. Okay, so I'm going to just multiply across, or not multiply across, but cross multiply. So I'll do the 10 times tan alpha first. So that's 10 tangent alpha plus 3 would be equal to 8 minus 24/10 tangent. Oop, I should do that in red. Let's do that in red. Tangent alpha. Okay, we're going to solve real quick for tan alpha and see what we get. Okay, so 10 is equivalent to 100/10. If I add 24/10 to that, that's 124/10. Tangent, I gave up on the colors. I just don't care right now. I'm going to subtract 3 from 8, giving me 5. And now I'm going to multiply both sides by 10 over 124. So let's visualize that. Multiply by 10 over 124. Multiply by 10 over 124. Okay, so the tangent of alpha is, what would that be, 50 over 124, which we could reduce, always fully reduce if asked. If not, if it's left in a vague form, then you can just leave as is. Okay, so there we go. Tangent alpha is 25/60. All right, guys, that's day 4. We'll see you in day 5. Have a great day.